Hello to all of you. How are you guys? So now we will understand the design stuff for deck type bridge. So now let's discuss about the bridge. Bridge are classified on the basis of at first material, traffic, main girder, and level of floor. That means loads also. And the codes used in this railway board, bridge code for design specification, bridge rules for loading, IS 800 1984 codes IS 800 1984 bridge rule according to the railway, and VIS IS 1915 and 1961. Okay, now let's start. What will the given data to solve any question? So we have to at first know about this. Given data will be in the question. First will be span of main girder, center to center bearing. Span of main girder, center to center bearing. And second, spacing of girder, spacing of girder. You have to arrange like this from the question. And self weight of stock rail, guard rail, that means self weight of given all the rail of rails. And weight of fastening, based of fastenings. Fifth, size of sleeper, size of sleeper. Six, spacing of sleeper. Seventh will be density of sleeper. Density of sleeper. And we will also find from the question gauge of rail, broad gauge, meter gauge, gauge of rail. And ninth number, type of rail loading case, probably used main line loading. We will also done the numerical of this deck type bridge plate. Okay, and the 10th is railway section track, which may be single, double, and multiple track. Railway section track. Okay, now we will draw a diagram to understand what is deck type bridge cross section view. This is sleeper, and we will also draw the rail. Okay, and girder also. Girder, we will design all the things which here we are drawing right now. This is girder, and also draw the support lanes. Now the design has been completed. We will also design of drawing also, so like this. for better support with each other. This is main girder. This is main girder, and this is deck type brace. Now we will also understood this is gauge from here to here. Gauge, which may be standard gauge, broad gauge, that means 1676 mm, meter gauge, that means 1000 mm, and narrow gauge maybe 767 mm or 610 mm, maybe whatever. And now we will understand also what is the check rail. This is the area of check rail, distance between check rail. And what is stock rail? This is stock rail. And now we will start to design steps. Okay, so step number first is calculation of loading. Calculation of loading. So at first we will find out dead load. Dead load we will calculate it by this. First, weight of rail, weight of rails, that will be multiplied by 2, that what is given, guard rail plus stock rail. And second, weight of fastening, weight of fastenings, which will be given, there is no change in fastening. And the third is weight of sleeper, weight of sleeper, which will density into volume of sleeper upon spacing of sleeper. We will define in the design when I will upload the video of numerical. You can easily understand from there, and it will be uploaded from 2 days at the same day. Total dead load, what it will the summation of these three. Okay, now step B, which is live load. Live load we will get from railway bridge rule. Railway bridge rule, I will also tell you this, that how we will get in the numerical. Okay, as per given gauge and rail loading conditions, it will evaluate from the tables for bending moment and for shear force both. Okay, now step C is impact load. What is impact load? Impact load is happen due to the live load. If there is no live load, there is not also impact load. So impact load, to calculate this, at first we have to evaluation impact factor. This is also given in the railway bridge, or have to formula to find out this. Okay, now what will impact load? Impact load for shear force and bending moment will be IF into impact load for bending moment, IF into live load for bending moment. And if impact load of shear force, then impact factor into live load, which are these two: live load for bending moment, live load for shear force, live load for bending moment, live load for shear force. Okay, then we will find out impact load by this, and we will also find out self weight of plate girder. Self weight of plate girder. Then we can find this by WL by 300, which will in kilonewton per meter. So W will dead load plus live load plus impact load, or and this live load and this impact load for shear force only, which is just have find out for shear force. live load for shear force and impact load for shear force. We will not consider live load and impact load of bending moment for the cell weight of plate girder to find this W here. Okay, now we will find out total dead load. Total dead load will be dead load which I find out in step number first A. Step number first A, you can see this, and plus self weight which I find out just in the step number first D. Step number first D, that means this is by the summation of these three, and it's assume also dead load for bending moment. This self weight, this also assumed dead load for bending moment and shear force too. This is dead load for bending moment and shear force to both. Okay, so now we will draw a table significant of load, which kind of loads will be act as dead load, live load and impact load, and finally we will total. Okay, now what is here for bending moment and for shear force. Okay, now step number E of the first step, load per track. We will also find out this step, load per track. Okay, for bending moment, total load per bending moment divided by 2. This which I have to find out, total load for bending moment divided by 2, total load for bending moment divided by 2. And for shear force, it will total load for shear force divided by 2, which will evaluate from here. Okay, now we will start step second. Step second will be calculation of bending moment and shear force. Calculation of bending moment and shear force. Okay, then how it will calculate? M equals to WL divided by 8. You know, here is not WL square by 8 because this is W in also in kilonewton only. Okay, load per track for bending moment, which I have evaluated in the step number first E, for bending moment into span divided by 8. And how shear force F equals to W by 2. What is W by 2? Load per track for shear force divided by 2. Okay, now we will find out step 3. What is step 3? Step 3 is calculation of size of wave plate and economical depth. Okay, then economical depth will be D equals to 1.1, and bending moment we just have find out in the previous step, and TW to the power 1 divided by 2. If you have any problem that how we will find out this, then you have to necessary to show my next video. Okay, then what is TW? TW is thickness of web plate. What is PM? PM is bending moment maximum, which is, and what is sigma B? Sigma B, as we just tell you, this is maximum bending stress, which is sigma B equals to 0.66 Fy. You can find out in IS 800 1984 and at the clause 6.2.1. Okay, now we will start step 4 after to find out D. Okay, step 4. What is step 4? Step 4 is the calculation of size of flange. Size of flange. This is a large step in the whole design. Then at first we will find out net area, flange, intention. Okay, what is net area, flange, intention? A dash ft, net area of flange in tension. Then it is maximum bending moment divided by sigma b into d. What is it? D is lever arm. Okay, now we will find out a dash ft from here. After to find out this, we will also calculate this, because we have to find out a dash p. Then how we will find out what is a dash p? A dash p is net area of flange plate. Then how we will find out? We know that a dash ft equals to ap dash plus a dash. What is ap dash? Net area of flange plate. And what is a dash? This is net area of angle section, which also a dash ft divided by 3. This is value of this. Okay, and plus aw divided by 8. This both is a dash ft and this is a dash f plus aw divided by 8. This is another equation, but we will start from here. This is a dash ft equals to a dash p, and we will put the value of a dash ft divided by a plus aw divided by 8. Then what have to do? Because we have to find out a dash p, net area of flange plate. Then we will replacement of these, we will transfer these two to another side. Okay, then it will a dash ft minus a dash ft, sorry, this is by 3, a dash ft divided by 3 minus aw divided by 8 equals to a dash p. Now we can write also to this, a dash p equals to 3 1 ja 3 minus 1 2 divided by 3 a dash ft minus aw divided by 8. Now we have got the formula of this. And what is the drawing section? I am also wanted to tell you, this is drawing section. We will also discuss in brief when I will make the numerical video of this. Okay, please don't miss to watch my next video. This is must to see all the okay, we will explain it in the next video. Now this is just roughly diagram. Okay, for the next, now we have got the formula of net area of flange plate. If we have to find out also the gross area. Then we will increase 120% area. We will increase 120% area for getting gross area. Okay, now we will start step number 5th. This is the last step of this. These 5 steps include many steps. If you will want to make more steps, you can write different as I have evaluated. Sorry, this is not in the first step. we write one, A, B, C. We can also write step number 1, step number 2, step number 3, step number 4, step number 5. Then it will many of the steps if you want to increase your step. Okay, check for stresses. Check for stresses. A, bending stress in compression flange. Compression flange. Okay, now we will find out sigma CBC. What is sigma CBC? M upon I dash XX into Y should be less than or equal sigma B. Both will be discussed in my numerical video. Okay, sigma B. What is sigma B? Bending stress. If you can find out these things, then you don't have need to watch my next video. But if you are unable to find out these things, then you should must to watch my video. Okay, bending stress in tension flange. We are discussing about bending stress in tension flange. Now we have to find out sigma bt should not should less from sigma v. What is sigma bt? Sigma bt is sigma cbc, which will be found out here. Sigma cbc into gross area. We will also make a table about to find out these two things, gross area and net area. Okay, gross area of compression flange. And this is gross net area of compression flange. Okay, now we can write here also sigma cbc. What will gross area of compression flange? Gross area of compression flange will be af plus 1 divided by 6 aw, and this will a dash f plus 1 divided by 8 aw. We will evaluate these two area by the table. Okay, which will just explain in the next video. Sorry. Okay, for the C step, check for shear stress. Check for shear stress in tension flange. Which is tau Vt, should less be from tau V. What is tau V? Tau V is 0.45 Fy. You can also find out at clause 6.4.1 in IS code 800/1984. Okay, and what is tau Vt? We will also explain you tau Vt. Tau Vt equals to shear force. Where we will get it? Shear force you will get it in step number 2. You can find out here. Okay, shear force divided by net area of flange in tension, which you will get from the table. Net area of flange in tension. Okay, and I also wanted to tell you the important values from code with page number. Okay, if we are talking about live load and impact factor, as per railway bridge rule, for broad gauge EUDL, equivalent uniformly distributed load in tons, for revised broad gauge standard loading will be get from 1975 in appendix number 20, which is given in page number 73. If you want to get EUDL, equivalent UDL, in kilonewton for 25T loading 2008 in appendix, then you have to visit appendix number 23, which is at page number 80 and 81. If you also want to get EUDL in kilonewton for modified broad gauge loading, which is of 1987 appendix Number second, you have to visit at page number 21. For meter gauge, if you have to get the appendix for NMG 1988, you will go there in the appendix number 4 for meter gauge. You will understood all the things, that what is the ML standard, VL standard, C loading according their years. And we will talk also about the impact factor. Impact factor, given the railway bridge rule, you have to download from the mobile, and yet I have not present to tell you. uh, by the way, I can tell you, according to the track, it's classified according to the track. For single track, impact factor is 1. For double track, impact factor is 0.72, and for multiple track, impact factor is 0.6. If you like this video, please subscribe my channel. If you don't like, you should not subscribe because you don't like, okay, but should share. Maybe someone who is urgently needed about to this video. Thank you.